I button, you can check out there. And we have already discussed implementation of linked list also, how to create these nodes, fine, and how to traverse the linked list, or you can say how to display the nodes, the data in the nodes, fine, how to display that data. So you can check out that video. I'll provide you the link of that video in the description box. Here in this video, I am going to talk about only the delete operations. I assume that you have already created a list, fine, this list, and we are having 4 nodes in this list, right? So if you want to write down a program, so you can implement these 5 functions in the program. First of all, create list. This coding we have already discussed in the previous video, so I am not going to write down code for this function, right? Next, display the list, that we have already discussed how to traverse or how to display the list in the previous video. And these 3 operations, from beginning, from end, and from any particular position. So I am going to write down code for these functions only, fine, and you can call these function in the main function, fine. So now, as we know how to represent this node in the list, how to declare that data type, that is a struct node, we have already discussed many times in the previous videos. So I am simply writing that thing here. So this is how we are going to declare that data type, that is struct node for this node, data part, and this next, this is going to contain address of the next node. This is how we are going to declare this. Why I am writing like this, we have already discussed, you can check out that video. One, also this head pointer we are going to maintain, because when we are performing the operation on linked list, then we have with us only this head pointer, means the address of the starting node. So we are going to create a pointer head, and this pointer is pointer to node, see, type is struct node, fine. Now you can write down the coding for this create list and for this display, fine. I am not going to write down these things. Now suppose you have created this list using this create list function, fine. Now I am going to write down coding for this function delete from beginning. How you will write down that thing? See, if you want to delete this node, this starting node, then simply what you have to do, you just point this head here, fine. In head, simply store this value, that is 200. If I store 200 here, it means this link has been destroyed, fine, and head is now pointing directly to this node. But now the problem is, see, although you have detached this node from this list, means you have deleted this node from this linked list, but now this node is still having some data, na? This node is still having some memory is allocated to this node. So you have to free that memory also, fine. You have to delete this node completely, you have to free that memory, that allocated memory, fine, because see, memory is very crucial resource in our system, so you have to manage that thing. This is what now a garbage, so you have to clean that garbage. And what function you are using in C, that is free. How you can access this node? Using a pointer, fine. So in free, in bracket, you will write a pointer to this node, fine. So now see, obviously you have to maintain a pointer to this node, right? So after updating this head node, you can do what? Free, and whatever the pointer is pointing to this node, you can write down that name, fine. So you are going to take another pointer, you can say temp or as you wish. So suppose the function name is delete from beginning, I am taking this function name, fine. So now we are going to take another pointer, you can say temp. So in this function you can declare another pointer, struct node asterisk temp, right? And now temp is equal to head. So now temp is a pointer and temp is containing whatever in the head. In head we have 100, fine, before this deletion. So now temp is also pointing to this node and head is also pointing to this node. Now you can do delete operation. Now what you will do, see, you just update this head value. So now what you will write, in head you will store 200. Now from where you will get this 200? See, 200 is stored in this, the address part of this node, or you can access this node either by this head or temp, because both pointers are pointing to this node now. So simply here you can write head next. In head next, head is having 100, head next. Using head you can access this structure node, and the next is the name of this part. So head next is having 200 value, so 200 is going to store in head. So now it is going to contain 200. So now this link has been destroyed, and now this head is pointing to here, to this node, directly to the second node. Fine. And now you can free this memory. So here after that you can write free. See now how you can free this node, how you can access this node using this temp, because temp is still pointing to this node. So here you can write temp. Fine. So now this is now free, this node has been deleted. So this is the reason we are taking another pointer, that is temp. See, in this function I have written just the main lines, fine, to delete this node. But if you want to check whether the list is empty or not, if list is empty, then which node you will delete? Obviously you cannot delete anything. So in this function you can write if head is equal to null, head is equal to you can say 0. If head is going to contain 0, it means there is no node in the list. So simply you can print what? List is empty. In else part you can write down this coding. Now next function is delete from end. How to delete from end? Now see, suppose this is our list, we have only now 3 node in the list after deletion of this node, right? Now I want to delete this node. How you will delete? Simply if I update this part of this node, if I store here 0 rather than this 400, it means this is not going to point anywhere. This means this link has been broken, and now you have detached this node from the list. But now you have to free this memory. This is now garbage. You cannot leave it like this. Fine. So now how you can free using this function? In the bracket you will write what? From which address you want to delete the data, which address you want to free. Fine. So here this address you want to free, so we can store this address in a pointer. You can say temp, same in this case, and you can write down free temp. Fine. So now to delete this node, you cannot directly delete this one. You have to reach till this node. Fine. And how you can reach? In linked list only sequential access is possible. So you have to traverse the list till here. Fine. So now how to traverse a list, that I have already discussed. See. So now the function name is delete from end. Fine. Same we are going to take a temp pointer another than this head pointer. Fine. Same in this function. See, we cannot use directly this temp pointer here, because see, this temp pointer we have declared within this function. So this is local to this function. So if you want to use this temp here, you have to again declare, you have to again write down this line. So the simple solution is outside all these functions, globally you declare this thing. So here you can declare what? One another pointer, that is temp. Now you can directly use temp here. No need to write down this line here. Fine. From here also you can delete this line now if you write down temp here. Now after traversing, suppose we have reached here. Now temp has reached here. Temp is going to contain 400. So now this is fine. You can say free temp and this memory is to be freed. But now before making this memory free, you have to update this thing. You have to store here 0. Now, how you can access this part of this node? Obviously, you can access only using a pointer. You cannot directly access this thing. But here, no pointer is there pointing this node. Then how you can update this thing? So you have to maintain another pointer. Here in this case, you have to maintain 2 pointers. One is going to point here, that node you want to delete for freeing the space. Another for updating this also you have to maintain another pointer. Suppose I am taking the name previous node, or you can take any name according to your convenience. Fine. Now suppose previous node is going to store 300. It is going to point here. Now you can do what? Now you can access this part. Now you can do what? Previous node arrow sign next is equal to null. Fine. Or is equal to 0. And after that you can write free temp. So to delete a node from the end, we are going to maintain now 2 pointers here. See, it's not like that it is the only way and you have to maintain 2 pointers. Maybe you can apply your logic in another way and using 1 pointer you can delete this thing. Fine. Maybe in free you can say temp next. To access this one, we just traverse the list till here from this end -1, and you can say temp next means 400. So here 400. So 400 is this location. So you can free that location from here only. So there are many ways. It is just one way out of all the possible ways. Fine. I'm not saying that this is the only way you can delete this thing. Fine. Now, here we have to maintain 2 pointers. So 1 pointer you can say this temp, another pointer previous node, you have to declare that pointer. So here I am going to declare that thing. Struct node, suppose name is previous pointer. So now how to traverse? Initially both these temp and previous would be pointing to this node, because from here we can start, only sequential access is possible. So now in temp we will store what? 200, because in head we have 200. Now temp is pointing here to this first node. Now we are going to start the traversing. See, you will write a while loop, while temp of next not equal to 0 or null. In that case you will write what? Obviously you have to maintain this previous node also, na? If you move this temp, then you are going to move this previous node also, because once the temp is going to reach here, then previous node should be pointing to the previous node of this temp. So both the pointers will move. So in previous node you will store temp, and after storing this value you are going to move this temp. Temp is equal to temp of next. Now see the working of this while loop. See, temp of next not equal to null. Temp is having 200. So using this you can access this node. Temp next means 300. 300 is not equal to 0. It means we are going to enter into this loop. Now in previous node you are going to store whatever is there in the temp, that is 200. So now previous node is also pointing to the first node, both temp and this one. Now we will move this temp. Temp is equal to temp next. Temp next 300. 300 is going to store in temp. So here 300. Now temp is pointing here to the next node, second node. Fine. Now again see, temp next not equal to null. Temp next means 400. Fine. Now 300 you can access using 300 in this node. Now temp next is 400. 400 is not equal to null. So again control will enter into this loop. Now again first of all we are going to update this previous node. In temp we have 300, that is going to store in previous node. So now here we will store 300. Now this previous node is also pointing to this node. Now we will move this temp. Temp is equal to temp next. So here we will store now 400. In temp next, that is 400 we have. So that is going to store in temp. Now temp is pointing to this node. Fine. Now see, temp next. Temp is 400. Using 400 we are accessing this node. So temp next is 0 now. Not equal to 0, this condition is not true. Now we are going to stop. Now we will not move this temp. As you can see, we have reached, temp has been reached to the last node, and that node you want to delete. Fine. And we have the pointer to the previous node also. So no problem is there. We can update this pointer easily and you can free this node easily. Fine. So now if you want to check out if, you can write down a head if condition. If this temp is equal to head, means temp is still pointing to the first node. It means we have only one node in the list. So you can simply write down head is equal to 0. So you can write down, if you want, you can write down one if condition. If temp is equal to head, in head you can store null, means head is not pointing anywhere. You have detached that node from the list. You have deleted that node, but you have to free that node. You have to take care of that thing also. So here you will write what? Free temp. Fine. Or in else part, what you can write? See, now here we have to store 0, that is null. So simply how you can access this thing? Using this pointer. Fine. So here you can write this previous node and next is equal to 0. Now this is not pointing anywhere. Now you can free this one. So you can write down free temp. See, one more thing, in both the if and else we are using free temp and free temp. So rather than writing twice, what you can do, don't write here in this case and do not write in else block also. After this else block means after this bracket, you can write down what? Free temp. And after that you can close this one. Because see, after this if also, if this condition is true, then after executing this, we are not going to enter into else block, and this statement is going to be executed, that is free temp. And if control will not enter into if block, then it will enter into else block, and after else also this statement is going to be executed. So rather than writing twice, you can simply write down this after this else block. So this is how we are going to delete data from the end. Fine. And you can call this function into main function, and after calling this you can call what? Display function. Fine. You can display the list, and what is going to be displayed? 3 and 9, because this is now not there in the list. We have only 2 nodes in the list. Now we will delete a node from any specified position. So now suppose I want to delete from third position, means first, second and third. This node I want to delete. User will enter the position, that is 3. So now this node I want to delete. Now logically, how you can represent this list after deleting this node? See, if you have deleted this node, then this link should directly point to this. Fine. So here in the address part of this node, rather than storing this address, we will store this address, that is 400. So here you will store now 400. It means this link has been broken. Fine. And you can free this node now. In free function, you can write down this address, or you can say the pointer, which is obviously the pointer is going to store this address, so you can write down free and that pointer which is going to point here. Fine. Now obviously to reach till this position, you have to traverse the linked list. Same, we are going to take another temp pointer. Fine, pointer variable, and we are going to traverse this one. Suppose pointer has been reached here, that is temp. So you can free this one. But how you will update this thing? How you will access this part of this node? Using a pointer to this node, pointing to this node, and using this pointer you can access this part also and this part also. And after that you can update this part. So here also we will have 2 pointers. We will maintain 2 pointers. Now see, to reach till this location, because if you want to delete this node, fine, so you have to traverse the list. Now let us suppose we have traversed the list till this position, till position -1, till this location. Fine. We are going to take a temp pointer, this one, and we are going to traverse this list. Now suppose at some point of time, temp pointer is pointing to this node, and this node is what? Position -1. Fine. Now we are going to stop here. Now what you can do, you can take another pointer and you can name it maybe next node. Suppose I am taking it next node pointer. Fine. So now what you can do for accessing this node, because we have pointer till this node only, so you have to free this node also. Fine. So now to access this node, this address, you have to store this address in another pointer, that is in this pointer we are going to store 300. Now this pointer is pointing to this node. Now from where you can get this 300? How you can store this 300 directly to next node? See, here we have 300 before updating this address. So from here I can get 300. So how you can access this part? This using this pointer, because this pointer is pointing to this node, temp next. So in next node you can store what? Temp next. Fine. Now we have both pointer, one is this one and one is this one. Now simply you can update the links. Fine. So now how to traverse the list? We are going to traverse till position -1. So within this function, one extra pointer you are going to declare, that is struct node asterisk, suppose next node. Fine. And we are going to store position. We are going to take input for the position from the user. So for that also you are going to take one variable, that is you can say post, and you are going to traverse this till position -1. So for that we are going to take what, one variable I, that is I is equal to 1. Fine. Now first of all we are going to start from here, temp is equal to head. So now temp is pointing here first of all to the first node. In head we have 100. In next node we have nothing. So after that we will write a while loop, that is while this I less than position -1. I is position -1 at starting, I value is 1, and suppose position is what? So before this while loop we will ask for the position from the user using printf and scanf. So here you can write, so this is how we can take the input in position variable, and suppose user has entered 3 here. Now position is 3. Now I less than position -1, I is 1, 1 is less than position -1 is 2, 1 is less than 2, yes. So here in while loop what you will write, we will move the temp, temp is equal to temp of next. We are going to move this temp till position -1, means this is position, so till here position -1. So here you will write I plus plus. Now how this while loop will work, see I is equal to, I is 1, 1 is less than position -1, that is 2, 1 is less than 2, yes, condition is true, so control will go into this loop. Now temp is equal to temp next. So temp next, temp is having 100, so using this we can access this node. Temp next is 200, so 200 is going to store here in temp, that is 200. Now temp is not pointing here, temp is now pointing here. Fine. Now I plus plus, I is now 2. Again 2 less than 2, no, this condition is not true, so we are not going to enter this, we are not going to move this temp. Now we have reached here, means we have reached till the previous node of our specified position. So now one step is over, we have reached here, we have a pointer pointing to this node. So we can access this part and we can easily update this part, we can easily store here whatever we want to store, that is we want to store 400. Now you have to free this node also. Fine. So we have taken another pointer, that is next node. Now in next node what you will store, this 300. How you will store this 300? This from this part, because here we have 300, so how you can access this part using temp next. So here what you can write, in next node, in this pointer you can write temp of next. Temp of next is 300, so here 300 is going to be stored, and now this is pointing here. Now we have 2 pointers. Now simply you can update this first and then you can free this node. So how you will update this? Here we will store address of this node, that is 400. From where you will get this 400? See, from here. Here we have 400. Fine. So how to access this part? To access this 400, obviously we need a pointer. So we have a pointer, that is why we are taking 2 pointers. So now you can access this thing. How? Next node and next node is 300 and next part is going to contain 400. Now where you are going to store this 400? In this part. How you can access this part? We have one pointer to this node also. So temp next. In temp next we can store this. Now here we have updated. Now this link is there and this link has been broken. Fine. So now you can free this. Free next node, because we are going to free this memory now. Fine. And this is done. Now this node has been deleted. Now we have, if you want to display the list after this by calling the function display, then 5, 6 and 2 would be displayed. So here I have taken 2 pointers. Maybe using 1 pointer you can apply the logic and you can delete this node also. So this is just one way from all the possible ways. This is not the only way to delete the node from a linked list. Fine. So now if you talk about the time complexity, see, in the previous case when we were deleting from the end, so you have to traverse the list till here, as we have seen. So time complexity would be, it depends on the number of node present in the list, that is order of n. This case we have already discussed when we were discussing the difference between array and linked list, that is order of n. And from beginning if you want to delete, then you don't have to traverse the list. It doesn't depend how many element in the list. You can simply delete this by updating this head. So in that case it was order of 1 only. And if you want to delete from any specified position, in that case also it is order of n. Why so? See, if you want to delete from here, so you have traversed this and this, 2 nodes. Fine. So obviously it is proportional to n only, number of elements. Fine. If you want to delete from the middle, then you have to traverse n by 2 elements. So it is proportional to n. So simply when you write in big O notation, so simply write order of n. In average case also, in worst case also, and the beginning is the best case, that is order of 1. In insertion also same time complexity is there. So in next video we will discuss how to reverse a linked list, as well as we will discuss about doubly linked list. Fine. And one more thing, it is 15th of August. So happy Independence Day to all of you. So I'll see you in the next video. Till then, bye bye. Take care.